Today we're going to have a look at adding algebraic expressions, and the first one we're going to do in two ways. We're going to use a method that we've used before where we simply eliminate the brackets and then look for like terms, and then we're also going to use another method called the column method, which is often asked as well, so you need to know that too. So let's start off with the one that we do know. So these first three terms are not involved in a bracket, so they're going to be simply written down as they are. And then when we have a plus outside a bracket, it's actually a very nice situation because it doesn't change any of the signs in the bracket, and we can double check that that is actually going to happen, because plus times minus will then remain minus, plus times minus, and you don't even need to do this because if there's a plus outside the brackets, the signs in the brackets are going to stay the same. I'm just trying to prove a point here. All right, so we've got to the situation where we have 6 different terms in our expression, so we need to start looking for like terms. Remember, like terms have the same variable to the same power, in other words, with the same exponent. So I've got an m squared term and an m squared term. I've got an mn term and an mn term, and I have n squared terms. So just tidying all of that up, I'm going to get 4m squared minus 5m squared is negative 1m squared. I don't have to write the 1, I can just write negative m squared. Negative 6mn plus 3mn is going to give me negative 3mn. And positive 2n squared minus 7n squared is going to give me negative 5n squared. And all of these are unlike terms, so I can't simplify further. That is my final answer. So we're now going to also look at doing exactly the same calculation or simplification, except we're going to use the column method. So the column method is just like when you're working with integers or whole numbers, where you write the one number underneath the other number. So what we're going to do now is we're going to write the one expression underneath the other expression. So I'm going to start off with my first expression, the one that wasn't in the brackets, and I'm simply going to write it down. And just to recap a little bit, if you have a look here, this is going in descending powers of m and ascending powers of n. And when we have an expression in two terms like that, in two variables like that, that is how we try to arrange it. So if we look at this one, we'll notice that it's not going in descending or ascending powers of the variables. So when I write this expression down, I need to make sure that each term is underneath the like term. So I've got a negative 5m squared, which I'm going to write underneath this m squared term. Then that term needs to go over there, so that will be negative 7n squared, and make sure you take its sign across with it. That's a very common mistake that people make. And then I've got an mn term and an mn term, and this is positive 3mn. Once I've done that, I get ready to add in columns. So when we're adding in algebraic expressions, the trick to remember is just do what the sign tells you. So you simply go like this. This is a positive 4m squared, so I'm going to say 4 minus 5 and in my m squared terms, and 4 minus 5 is negative 1, which is negative. Here I'm adding up mn terms. Let's see what I get. Negative 6 plus 3 is negative 3. And then adding up my n squared terms. When I'm adding, I simply do what the sign tells me. Positive 2 minus 7 is going to give me negative 5. So the only tricky thing that I had to watch out for here when I was using the column method was, because it's in columns, just like if you were adding a number in, let's say, the 10,000s, you would make sure that the 1,000 digits were under the thousands digits and the tens digits were under the tens digits. In other words, everything would have to be in the correct placeholder position. So now you're making sure everything is in the correct like term position. And if you look at the two answers, they are exactly the same. So let's look at this question down here, which says use the column method. So it's asking me not to do that. To find the sum of. All right, so we need to know maths vocabulary, which I keep saying is so important. So we need to know what the sum of means. And the sum of means that they want you to add. There are 4 different words for the 4 operation signs, and I do deal with them over and over. Try to remember, because otherwise you won't know what the instruction is for this actual sum. So I've got a trinomial, and a trinomial, and I have to use the column method. So I'm going to write the first one down as it is. Right, my second one, if I look at it carefully, it's not going in descending powers of x. So when I write it down, I've got to be very careful. That's going under the x squared, or into the x squared column. Let's say it like that. I need an x term now, so it's going to be plus 3x. And then take the sign with it. That's a negative 5. This one is in descending powers of x, so I'm simply going to write everything down as it is. And once I've done that, I'm ready. And remember, I am adding now. And when I'm adding, I simply do what each sign tells me. So in my x squared column, I've got 4 plus 3 is 7. 7 minus 6 is 1. Remember, I can write the 1 there, but we don't usually. We just leave it as x squared. In my x column, I've got negative 2 plus 3 is 1. 1 minus 4 is negative 3. And in my constant column, 1 minus 5 is negative 4. Negative 4 minus 2 is negative 6. And there is my final answer. We will be looking at more forms of simplification over the next few episodes of this series. So if you don't want to miss them, please press that subscribe button.